Good morning, everyone. In the last class, we have seen about the types of faults and the zones of protection. What are the types of faults and for what faults the relay is going to sense, and what are the zones of protection for different equipments in power system. What is the overlapping of zones that we have discussed in the last lecture. Today we are going to discuss about the basic requirements of relays and the types of protection. So what are the basic requirements of the relays? Reliability, selectivity and discrimination, speed and time, sensitivity, stability, adequateness, simplicity and economy. These are the requirements of the electromagnetic. So what is reliability? Reliability is nothing but the probability of the product or the device or the equipment whichever we are using in service that should without any failure over a specified period of time. Suppose if we took a generator, suppose its lifespan we assume it has to be a 5 years, then it should be work without any failure. In this service of time it should work. How this will be achieved? Nothing but the maintenance. Careful maintenance we need to do. Next is the selectivity and discrimination. Selectivity and discrimination is nothing but protective system. Whatever the system we are going to be protected, that should work under its zone of protection. Suppose consider generator C and its zone of protection area is this one. If the fault occurs beyond this zone of protection C and this is the suppose fault occurred, then whatever the equipment which is going to protect this generator zone should detect for the under this zone only. I should not detect the faults for the outside zone of protection, because for this protection also there is one other protection scheme will be employed. So it should not operate for the faults beyond the protective zone. That is nothing but the selectivity. Discrimination is nothing but normal or abnormal condition, whether it is a normal but whether it is a normal behavior of the equipment or whether it is a behavior under fault condition that need to be detected. That is nothing but the discrimination. Suppose if we are switching the loads, all loads at a time and for 1 second and we are off, then it is nothing but it is a fault, right? So that discrimination should be done by the relay. That requirement should be there. Suppose consider a transmission line section, this section 3 if we consider if the fault occurs at F2, then the corresponding schemes should be worked. But the other circuit breaker, say this A circuit breaker or this circuit breaker or this circuit breaker should not trip, because for that part whatever the protection scheme employed that should be worked. That is nothing but the selectivity. Speed and time. Suppose if there is a fault in the system, if it is not disconnected, what will be happening? The total power system that will be going to get damaged. Whatever the equipment which is in the power system that is going to get damaged. So what we need to do whenever a fault occurs, in the system, whenever the relay is sensing, it should disconnect with the faster speed and in the less time. So the speed of operation of the relay should be high. This is the sensitivity. Sensitivity is nothing but is to detect any fault or work properly to avoid mal-operation. Means the relay should be able to sense each and every fault and it should not avoid any mal-operations. Nothing but it should work for any mal-operation. Suppose there is a fault and if the relay does not sense, then there is no sensitivity for that relay. So it is sensitive enough to detect any maloperation. That is nothing but the sensitivity. Next is what is the next one, that is stability. Suppose there is faults coming under this system, under the power system or any maloperation, the system should not lose its stability. Yes, the protective system should provide adequate protection for any element. We are using generators, transformers, transmission lines, or bus, whatever we are using in the power system. That equipment is going to protect. So adequateness is nothing but we need to protect the equipment, any element in the power system, and nothing but and also each and every second it should be able to detect the fault. It's nothing but for within a 5 minutes of time. If the fault occurs in the first minute and in the second minute also it occurs, then it should be able to detect in each and every minute. That is nothing but the adequateness. Next is the simplicity and economy. Simplicity and economy is nothing but we need to give the maximum protection for the power system and it should become under our minimum cost. That is our aim. Suppose consider the total cost of the equipment 5,000 and the protection device cost is also 5,000. What is the use of using the protection device? The cost should be minimum. The device cost, protection device should be minimum. Suppose generator cost is 5,000, then the cost of the protection device should be less than 10% of that 5,000. These are the basic requirements of the relay. There are two types of protection. One is the primary protection and other is the backup protection. Primary protection name itself indicates that this is the main protection scheme, first line of defense that need to that protection for the equipment from faults. When backup will come? When primary fails. So backup protection will comes under picture whenever there is a failure in the primary protection. Why the primary protection fails? The primary protection may be fails due to there is a circuit breaker problem, failure in circuit breaker, or there is a failure in relay, or whether a tripping circuit is not tripped, or whether a DC tripping voltage is not there, whether loss of voltage or current to the relay. So mainly these are the reasons for the failure of main protection. 95% will not be any failure to the main protection scheme, but there are fair chances. If suppose the main protection fails, what happens to the power system? What happens to the equipments which are connected in the system? So keeping in this idea, we will go for backup protection. Nothing but the same main protection scheme, also one backup protection scheme we will be employing. Protection fails, then we need to protect our system. So for that case, we are employing backup protection if in case the main protection fails. So consider, suppose this is the transmission line section we are considering, we are going to protect. So this C and D comes under the G and H comes under primary protection. Suppose this protection fails, then the system will get damaged. So there is a backup protection scheme provided, that is AB and IJ. This is backup protection. So here it is mentioned as primary relays and backup relays. Our system from the faults. Next is the basic relay. Here I am explaining about the basic working principle of relay. See, this is the basic electromagnetic relay. What are the main parts? String, armature, yoke, soft iron core, and fixed and movable contacts. These are the main components. What are the main components? Electromagnetic coil, armature, spring system, yoke, fixed and movable contacts. These are the main components of the electromagnetic relay. So the operation, now I am explaining the same picture. See, this is an electromagnetic coil and this is an armature and this is the spring system and this is the yoke and these are the fixed electrical contacts and this is the movable contact. And here this electromagnetic coil is wound with a wire. See this electromagnetic, here a soft iron core is there. This soft iron core is wound with this electromagnetic wire. Here, see, if we give supply to the system, then because of this soft iron core as is wound with a coil, there because of the supply in the system, there is the production of this electromagnetic field. The yoke is provided to provide the reluctance path for the magnetic field produced by this coil. See here, there is an air gap between iron core and the armature. Whenever, see, this is the air gap when it is under de-energized state between the soft iron core and this armature, there is an air gap present. So now we are giving a supply. We are giving supply to the relay, then these will be getting energized as this electromagnetic coil will give the electromagnetic field. There will be the attraction of the soft iron core towards this armature. But continuity of this supply, there is an, because of this field, electromagnetic field effect, soft iron core will be getting attracted towards this armature. As it is getting armature attracted towards the armature, these contacts, see, first these contacts are in normal close and these are normally open. Whenever there is a continuous flow of the supply and as this armature and the soft iron core are getting attracted because of due to this magnetic field, then this normally closed contacts now will become the normally open and normally open contact now become normally closed when the relay is under energized condition. So nothing but after this relay is getting operated and that will be given to the CT to the circuit breaker, then trip circuit will give the trips the circuit from the healthy portion of the power system. The basic relay. So what we have learned in this session, what are the requirements of relay, what is the primary protection and what is the backup protection, and basic operation of relay we have studied in this lecture. Thank you everyone.